Right, okay, let's have a look at this past paper question. It's 4 marks, and it's really typical of the kind of thing that comes up a lot on a Unit 1 paper. Okay, so student uses a ruler to measure the sides of a copper block. He records the measurements as, so the measurements are given as length, breadth and height. They're quoted in centimetres, and they're given with a plus or minus 0.1 centimetres as the uncertainty. Okay, so you've got length, breadth and height. And you've also got data for the mass of the block, 670.8 plus or minus 0.1 grams. So you've got the mass and the uncertainty there. Okay. Use the data to determine a value for density in grams per centimetre cubed and the absolute uncertainty. So this is a case of where we need to quote the density, but plus or minus however many grams per centimetre cubed. All right, so there's your formula. Density equals mass over volume. If we do the easy bit first, so the mass is 670.8 and the volume is length times breadth times height, or whatever you want to call it. 5 times 4.2 times 3.6. And you can work that out on your calculator. And it is 8.86 grams per centimetre cube. We'll look at significant figures in a moment. All right, so uncertainties next. Let's look at the uncertainty. So this is the estimated uncertainty for the mass. There's no range of values. If you had 3 different trials or 5 different bits of data, you find half the range, but we're just using the uncertainty of the instrument. So the uncertainty for mass is 0.1 grams. And then the percentage uncertainty for mass is the uncertainty. Do you remember the uncertainty over the mean times 100? Remember that? So we've got 0.1 over 670.8 times 100 equals, and that comes out at 0.01%. Okay, now your percentage uncertainties must only be to one significant figure. All right, so all percentage uncertainty is one significant figure. Your calculated data should be a similar number of significant figures as your measured data. So if you look back in the guidance, it says, for instance, if your 2 quantities, so you've got 2 significant figures and 4 significant figures, you use the least accurate one. So you would you would state your answer for your calculated quantity just to 2 significant figures, which is your least. And that's the case here. Look, these measurements have only 2 significant figures. This has 4 actually, but you use the least accurate. So this actually 2 or 3, I think the guidance says, but best answer would be to round that to 8.9, which we'll do when we get to the bottom. Okay, so we've calculated the uncertainty. Sorry, we've quoted the uncertainty for mass using the resolution of the instrument, and we've calculated the percentage. All right. Now we're going to look at the uncertainty for length, the uncertainty for breadth, and the uncertainty for height. And they're all the same. They're all 0.1 centimetres. And again, it's using the resolution of the instrument. Now the percentage uncertainties are all slightly different because you calculate those. So percentage uncertainty for length is the uncertainty for length over the mean or the best value, the measured value, times 100. And for breadth is 0.1 over 4.2 times 100. And for height it is 0.1 over 3.6 times 100, and those come out at 2% and 2.4% and 2.7%. Now these should be rounded just to one significant figure. Remember, all percentage uncertainty is one significant figure, but I'm going to add them up because I want the percentage uncertainty for volume. And that is 2, add 2.4, add 2.7, and that is 7.1, and now I'll round it. Okay, so I've got a percentage uncertainty for volume, and I've got a percentage uncertainty for mass. So percentage uncertainty for density is percentage uncertainty for mass plus the percentage uncertainty for volume, and again it rounds up to 7%. Okay, so now I know that my density for, what is this, the copper block is, and I'm going to put two significant figures because that's the best accuracy in the measured data. So I'm going to stick with 8.9, and I need to know what 7% of 8.9 is. What's 7% of 8.86? Well, that is 0.62 grams per centimetre cube. But again, let's keep this the same, 8.9 plus or minus 0.6 grams per centimetre cubed. Okay, so I've got my, that's the easy bit, working at the density. Working at the absolute uncertainty is a lot more work. And it involves, first of all, calculating the percentage uncertainties, adding them up, and then working out the absolute uncertainty for density. Okay, so if you write this up, you can print this question off or you can write the question out in full, but go through this, write this up step by step in your book, make sure you fully understand, rewind it as many times as you need to, put a question if you're uncertain about anything, because this is the technique that you need to do those two assessed homework questions.